Okay, now let us look at this question. Yeah, a progressive wave is represented by this equation, y equal to 5 sine 2 pi t minus pi over 2 x. Okay, where y and x are in centimeters and t is in second. Okay, now define all the amplitude or angular frequency, wavelength, period frequency, wave speed, and direction of motion. Good. So first of all, what we do is we must pay attention to the unit. This is centimeter and this one is in second. So the y and x is in centimeter. This is very important, and this one time is in second. So we can know that this displacement and this position x both are centimeter, and so the amplitude also in centimeter, and the wavelength later on, the k is in also centimeter. I mean the wavelength also in centimeter. Okay, because based on y and x centimeter. Okay, and the time is in second, so later on our period also in second. Yeah, not millisecond or whatsoever. Yeah, so the omega is per second. Okay, so that's all for the units. So now I want you to get the amplitude, angular frequency, all. We need to compare this formula with the general formula. Let's write down the general formula. Write down this formula given first. Okay, so what's the general formula? General formula is y equal to A, amplitude, sine, and then omega t. T is omega. And then plus minus kx. So from here we can compare time with time, x with x. So that's why we know this omega is 2 pi and k is pi over 2. So compare and we get this is the amplitude, and this is the omega, and this is the k. Okay? So from here we can know the all the values. Okay, all the values. So I just okay. So okay, maybe I just put it over here. Now, what's the amplitude? What's the amplitude? Amplitude is so from here we can see this amplitude is 5 cm. Why centimeter? Because follow the displacement. Okay, so this is amplitude is 5 centimeter. Okay, good. So B, what about the angular frequency? Angular frequency is no, not B, still is. Okay, maybe you should write down. This is the, we want the amplitude. The angular frequency is omega, wavelength. Okay, wavelength lambda, period, frequency, wave speed. We need to find the wave speed, which is the v equal to f lambda, and the direction of motion. The direction. Yeah. Good. So we got the amplitude. Omega is 2 pi. Yeah, omega is 2 pi. And the unit is you can write as radian per second. Okay, or per second also can. And then how about the wavelength? How to get the wavelength? First of all, we know that the wave number k is actually pi over 2. Don't put the negative sign. Don't put the negative sign. No. Yeah, just pi over 2. Pi over 2. K is pi over 2 radian per centimeter. Yeah, this unit is centimeter per centimeter. Because why per centimeter? Because our k follow the x. Our x is centimeter, so our k is per centimeter, not per meter. Be careful with the unit. Okay, so that's our k. So we can find the wavelength from here. K is the wave number is 2 pi over lambda. 2 pi over lambda. This one is pi over 2. Okay, so so we cancel, and then afterward we cross multiply. Okay, cross multiply, we get 1. This is 1 centimeter. Wait. Let me look at carefully. Yeah, we cross multiply. Sorry, I cross multiply top. This one multiply. Oh, this is 4 centimeter. Lambda is 4 centimeter. So not for 4 meter, it's 4 centimeter because our K is per centimeter. So lambda is 4 centimeter. Okay, that's the answer. That's the lambda. And then what's the period? What's the period? What else? What else do we need? Period is we find from omega. Omega is 2 pi over period. 2 pi over period. So 2 pi over period. So omega is 2 pi over period. So from there, we can get our period. We can get our period. So our period is cross multiply. So we got 1 second. That's our answer. 1 second. Okay, 1 second. And then what's the frequency? Frequency also we can do from the omega. Frequency we can find from period. Okay, frequency is 1 over period. So our period is 1 second. 1 second. So our frequency is 1 hertz. 1 hertz, or you can write as 1 per second. Okay, that's the answer. We got all the answer already actually. Yeah. Yep. Okay. And then what else? Wave speed. How to find wave speed? Wave speed is V equal to F lambda. V equal to F lambda. So our frequency is 1 hertz. 1 hertz. Our lambda is 4 centimeter in centimeter. So our wave speed is 4 centimeter per second, not 4 meter per second. 4 centimeter per second. Be careful. Okay. And then what's the direction of motion? The direction of motion, just look at this equation. This is negative kx. Negative. When we minus something in the angle, look at this one. Oh, sorry. You see, when we minus something in the angle, we shift the wave to the right. Isn't it? When we minus something in the angle, we shift the wave to the right. Like this one, we shift the wave to the right. See that? This one, if plus something, you shift the wave to the left. If you minus something in the angle, we shift the wave to the right. So this one, you minus something in the angle, you shift the wave to the right. So the wave is travel to the right. Okay. So this one, from here, this one negative here, it means the wave is travel. Wave travels to the right. Oops. Okay, wave travels to the right. That's the answer. Okay, minus something in the angle means the wave travel to the right. Wave travel to the right. Okay, so is the answer correct? Let's check the answer. Okay, so this is amplitude is 5 centimeter. Yeah, just check over here. It's all correct. Yeah, omega is 2 pi per radian per second, and then the wavelength is 4 centimeter. The period is 1 second. The frequency is 1 hertz, and then the wave speed is 4 centimeter per second. That's correct. All the unit also correct. Good. So we done that. So we proceed to question B. Let's do the question B. Yeah. Now we need to sketch the displacement against distance graph for progressive wave above in the range of 0 to x. That means in the range of x between 0 to 2 lambda. So we need to draw at least 2 wavelength. Yeah, 2 wavelength. At time t equal to 0 second. So how to do this? First of all, we substitute the time. So what graph we need to draw for this one? If you look carefully, B, C, D, E. B, we need to draw graph y versus x graph. Yeah, we need to draw y versus x graph for at time 0 second. Yep. So be careful. for at time 0 second. Okay, for question C, we also need to draw y versus distance graph. Okay, y versus distance graph, that means y versus x graph, for this time, okay, for this time 0.25 period. Okay, and then for D and E, we need to draw displacement against time graph. Okay, that means we need to draw y versus t graph for the particle at this position, x equal to 0. You need to substitute this one, x equal to 0. And then for question E, we need to draw y versus t graph, okay, for this particle at this position, which is x equal to 1.5 lambda. And be careful, we need to know the range of it. So like for example, like for question B and C, we need to draw at least 2 lambda. You see, the wavelength required is 2 lambda. And for the D and E, the range required is until 2 period. That means also 2 wave lah. Okay. So these are the things you need to know. So for this video, I'm going to show you B and C first. Okay, I'm going to show B and C. So I start with question B. Okay, how to do question B? Okay, question B. Okay, so okay, we need to draw a y versus x graph. We need to draw a y versus x graph at this time, at time equal to 0 second. So this is the first thing you need to write first. This is the first thing. Okay, so what you do is you use the formula, substitute the value t equal to 0. Okay, write down the formula first. Write down the formula, y equal to 5 sine and then 2 pi t minus pi over 2 x. Okay, then you substitute the time equal to 0. Okay, substitute this time equal to 0 over here, and what do you get? So you get 5 sine, and then this one becomes 0. This one becomes 0 because anything multiply 0 gets 0. Minus pi over 2 x. Okay. Yep. And what graph do we get? We get 5 sine, a negative pi over 2x. Okay, now you have a negative sign here. You cannot leave it negative. You must change it to positive. How? You must remember the trigonometry you have learned in your mathematics. Okay, so this one. You must remember about this mathematics. Let me show you. This one that you have learned about this. Okay, you learn about the quadrant, isn't it? You learn about the quadrant. This is the CAST. I learn using the synonym acronym CAST. Yeah, CAST. I begin with this one, CAST. So if negative, if you have a, let's say, negative angle means it is, we know that another thing we must know is if the angle is positive, that means it is anti-clockwise. Isn't it? If the angle is negative, means it is clockwise. Okay? So now you have a negative angle. Negative angle, that means it's clockwise. So your angle is at the bottom here. Yeah. First of all, hold on. I want to copy this, put it in somewhere first. Okay. Okay, for use later on. Yeah. Yep. Okay. So now let's continue. Yeah, let's continue our work. So now, okay, this one also I want to group it. Okay, so now we have a negative angle. Negative angle means clockwise. Clockwise. That means the angle is clockwise, like that. This is a negative angle. Negative angle. So it is clockwise. So you are in what region? You are in cosine region. You see that? You are in a cosine region. Cosine region is not the cosine region is not the region for the sine. You are in the wrong region. You understand or not? Your sine, you are in other people region. If you are in other people region, you become a negative sine. Your equation become negative. Your equation become negative. This one become negative 5 sine, and then this one become pi over 2 x. Because you are in other people region. If you are inside your own region, like for this A is for all, that means this is all. This A means for all. This S means for sine. This T is for tangent. C is for cosine. Now you are in other people region. That means that's why you will become negative sine. Because you are in other people region. You become negative sine. Okay? Because you are in other people region, cosine. So you are not in your own region. You are not in your own region. You are in other people region. So this equation become negative sine. Okay? Yeah, negative sine. So this is the equation. This is the graph. This is the equation for the graph. You are going to draw a y equal to negative 5 sine graph. Negative sine graph. You need to draw a negative sine graph. Okay? So how to draw? Let us draw it. Yeah? Let us draw it. Let's draw it. Okay? So we need to draw a graph. Yeah? Okay, now let's continue. Yeah? Recording. Okay, so now let's continue. Okay, so we need to draw what graph? We need to draw y versus x graph, isn't it? We need to draw y versus x graph. So here we plot this is y versus x graph. Okay, y versus x graph. This one I just want to adjust a little bit on top so that my work not become messy. Yeah. So this is a y versus x graph. You need to label the unit. My unit is in centimeter. You see that? Unit is centimeter. My y and x both in centimeter. Both in centimeter. My y and x both in centimeter. Both in centimeter. Okay. You need to draw what range? We need to draw 0 to 2 lambda x. 0 to 2 lambda. That means I need to draw a range of 0 to 2 lambda. Yeah? 0 to 2 lambda. Okay, 0 to 2 lambda. Okay, 0 to 2 lambda. So that means this x I need to put until this is considered, I put here as 1 lambda, and this is 2 lambda. I need to have 2 lambda here. Okay, I must show because the requirement is until 2 lambda. So I must put my graph as 2 lambda. Okay, but the thing is, don't put just value. Don't put just the symbol. You must put value because you already calculated the lambda here. This is 4 cm, isn't it? So 4 cm. So this perimeter is in centimeter. So this lambda here we put as 4. Put as 4. And this one is we can put it as 4, and this one is considered 8 centimeter. Okay. And how about this one? Here should be 2 centimeter, and here should be okay. Maybe I should write like this. This one as 4, and this one as 8. Because this one is considered as 1 lambda. This one considered as what? This one is considered as 2 lambda. Okay, in centimeter, isn't it? Centimeter. So this is 4. This is 1 lambda. This is 2 lambda because the requirement until 2 lambda. Yeah. Okay. 4 and 8. Okay. So and this one should be 6. Yeah. 1 lambda, 2 lambda. So I need to draw. Okay, and then the amplitude, I need to set the amplitude. So what's the amplitude? 5 centimeter. The amplitude is 5 centimeter. So I write as the parameter also. I must label the unit, centimeter. Centimeter I must label here. So this is 5. Yeah, here should be the 5. Here it should be the negative 5. So this is the amplitude, and this one should be the negative amplitude. Okay. Once I finish this, I draw a negative sine graph. A negative sine graph looks like, because a sine graph is, a sine graph is like this. This is a sine graph. So it becomes a negative sine graph. It becomes this way. Opposite. This is a sine graph. This is a negative sine graph, isn't it? Okay. So that's the way lah. Okay. So this is a sine graph, and this is a negative sine graph. We need to draw a negative sine graph. So negative sine graph is the opposite. So we draw. We can draw already. So let's draw it. Yeah. Let's draw it. So this is our negative sine graph. Just plot first. Okay. This is one wavelength. Here until here, this is considered one wavelength. So that means it must complete until here. This one is 2 lambda. So that means we can plot first. We can plot. This one must be one wavelength already here. This one must be 4 centimeter. Must be one wavelength. So consider it go back to here also. So that means negative sine graph is here, plotting here and here. One wavelength. One wavelength. Yeah. One. Until the amplitude. Oh, sorry. And then until the amplitude here. One wavelength. 4 centimeter. Understand? Negative sine graph. 4 centimeter. And then later on, also here we need to plot. Repeat the same graph. Negative sine graph. This is the one. Okay. This is the graph for, okay, amplitude. Remember. So this is the graph for this equation. Okay, we got the graph. Okay. So now let's move on to the next question. Yeah, we got the negative sine graph for 2 lambda. So now let's move on to C. I need to draw also y versus x graph for at this time 0.25 period. Also the requirement is until 2 lambda. So how to do this? A little bit difficult. We need to substitute this time into equation first. Okay, let's do it first. So for this one, let's take a deep breath and we start doing it. Yeah. So don't be panic. We take a deep breath and everything will calm down, and we will do things much easier later on. Yeah. So okay, we need to draw y versus x graph. We need to draw y versus x graph at what time? At this time. At this time, 0.25 period. Okay, 0.25 period, and also in the range until 2 lambda. Yeah. So the range also. Okay, just make it below here a little bit. So I also want the range between 0 to 2 lambda. Okay, good. So now this is our what we want to draw, y versus x graph. Yeah, y versus position, displacement versus position graph. Okay. So now we need to substitute this time into the equation first, into the general equation first. So let's write down the general equation first, which is y equal to the equation is over here. Okay, 5 sine 2 pi t, and then minus pi over 2x. Okay, good. So let's do it. Yeah. So now let's substitute this value into this time into here. Okay. So let's substitute first. Do step by step. Yeah, and the weight will be lifted up from you. Yeah, the weight will be lifted off from you, and we'll find it easier later on. Yeah. Okay. However, this time, okay, we already got the period, isn't it? Period is 1 second. Period is 1 second. So actually, this one is 0.25 period. We further write it as 0.25. We substitute the period. Period is 1 second. Period is 1 second. So this is 0.25 second. 0.25 second. So just substitute inside our time here. Our time actually is 0.25 second. Yeah, after we substitute the period as 1 second, so we already got the time 0.25 second. So this is 0.25, yeah, in second, yeah, unit second, and then minus pi over 2 x. Pi over 2 x. Okay, good. So continue. We are going to get easier, yeah, later on. So 5 sine, and then 2 pi. Okay, sorry, this one is how many pi then? 0.25 multiplied 2 is 0.5, isn't it? We got, this is 0.5 pi, yeah, 0.5 pi actually is 0.5 pi is actually 1 pi over 2. This is pi over 2 already, yeah. 2 multiply 0.25 is actually 0.5, isn't it? 0.5 is half. So that's why it become half pi. It become half pi. Okay. Just want to show you lah. Okay. So it become half pi, and then minus pi over 2x. Okay. Now we cannot draw this graph first. We cannot draw this graph yet. Yeah. We cannot draw this graph yet. What we have to do is, because we want to draw y versus x graph. Y versus x graph. But our x is actually at the behind. You cannot let the x at behind. You must make it at the front. Okay, must make it at the front. It's just like this one. When you're drawing any graph, your x or your anything, your x-axis need to be at the front. All the numbers behind. You see that? Plus 1, whether it's plus 1 or minus 3, all the value, all the numbers need to be behind. Your x-axis need to be at the front here. So now your x-axis at the behind, your number at the front. So you must adjust this formula to make the x-axis at the front and then the number go behind. Okay, so what you do is, look what you do is, this one also equal to this one. We have okay, now I'm okay. Look at here. Okay, now look at here. So I must make this x in front and the numbers go behind. So I just adjust first. I just rearrange the position. Okay, and then this one is positive pi over 2. Okay, now this one, remember, when we want to draw the graph, you cannot straight away draw a sine graph. This one, the negative sign here, look at here, the negative sign here, you must change it to positive. So remember, when we draw any graph, yeah, the front part here need to be positive value. Need to be positive value. You see that whether it's omega t or kx in front, no matter it's omega t or kx at the front, they need to be positive. Only the value behind can be positive or negative. Understand? If not, you will get confused later on. Okay, just make sure the front part here need to be positive value. So how to make it positive? Very simple. How to make this value positive? Like this. This one, to make it positive, you just take out the positive. Just take out the negative. Take out the negative from the whole angle. So when we take out the negative from here, so this one become pi over 2x positive. We take out the negative already. When we take out the negative sign, this one become, this negative kx become positive, and then this pi over 2 become negative. Because we take out the negative, this one, the positive become negative. Understand or not? When we take out negative from both value, this one negative become positive, this positive value become negative. It's just like you, let's say later you want to expand, you negative multiply inside, you get back the negative sign. This one negative multiply the negative, negative multiply negative, you get back the positive. You understand or not? It's just like we take out the negative from both, the negative one become positive, the positive one become negative. So then from here, apply this knowledge. This one. Okay. This one. Okay. Put it over here. This one. Still remember this one? This is what graph is this? This is negative. This angle, you see, this angle, this whole thing is an angle. You see, this is like, this whole thing is just like negative, and this whole thing is like negative angle. Understand or not? It's like negative angle. It's just like sine negative theta. Okay. This whole thing is just like sine negative theta. So when we have negative angle means it's clockwise. Okay. Clockwise. So clockwise. Now the angle is clockwise. So that means the angle is in the cosine region. And you are sine. Your equation is sine. You are not cosine. You are in other people region. So you become a negative sign. You become a negative sign equation. And this one become a positive. Yeah, remember this one, sine negative theta is actually negative sine theta, isn't it? Isn't it? Remember that? Sine, your mathematics, sine negative theta is negative sine theta. Whereas the other partner, if you have, let's say if you have cosine negative theta, you will get if cosine negative theta means is clockwise. So if cosine negative theta, you are in your own region. Your angle is clockwise, so you are in the cosine region. And cosine negative theta is in your own region. So you become positive cosine. So cosine negative theta is cosine theta because you are inside your own region. But if sine negative theta is not inside your own region, you are in other people region, you become negative sine theta. So that's why sine negative, the whole thing become negative sine graph. That's why it become a negative sine graph. Understand or not? Okay. So okay, the rest, then you can, this one becomes sine pi over 2 x, and then this one negative pi over 2. Okay, this is our final equation to draw our graph. Okay, so how to draw the graph now? Let's draw the graph. Yeah. So very simple. For this equation, we actually just use back our original equation, original graph. This one is the original graph, is the negative sign graph, which is this one. This is our original graph, isn't it? Negative sine pi over 2x. So we are going to use back this equation, this graph, and then what we do is look at this part. We negative. We shift. What this means by, you see, these two equations is still the same. Negative 5 sine pi over 2x. Negative 5 sine pi over 2x is still the same graph. What different is, you inside the angle you minus, you got minus something. So it's just like this one. It's like originally you have a, let's say you have a sine graph, and then you minus something. Understand or not? Originally you have a sine graph, then you minus something. What happens if you minus something in the angle? Minus something in the angle? You shift the graph to the right. If you minus something in the angle, you shift the graph to the right. If you plus something in the angle, you shift the graph to the left. So we apply this. We apply this knowledge. When you minus something in the angle, you shift the graph to the right. Yeah, you shift the graph to the right. You see the red dot is shift to the right. This is the thing. Okay. So now for this equation, okay, we have this original graph. Let's draw this original graph. Yeah. Okay. You look at here. Yeah. You look at here. I'm recording. Okay. So look at here. This is our original graph just now. Negative sine graph. Negative sine graph. Yeah. From the top. Negative sine graph. This is the graph we have. Okay. So this is the graph we have for negative sine graph. Now we need to minus something in the angle. Minus something in angle means I shift the wave to the right. When you minus something in angle, you shift. Okay, maybe I can write something there. Look at here, yeah. Look at here. So negative pi over 2 means negative. You minus something in the angle means you shift the wave to the right by pi over 2. Pi over 2 is 90 degree, isn't it? Pi over 2 is 90 degree. So you shift the whole wave to the right by 90 degree. How are you going to do that? Just look for one point. If we shift this wave to the right by 90 degree, that means the wave will becomes behind this. Okay, wait, hold on a second. Okay. Look at here. So before this, this graph is actually behind. Yeah, you have some more graph behind. You want to shift the wave to the right. That means you must know what's the graph behind. So the graph behind actually is going up, to here some more. Yeah, going up some more until here. Going up some more, and this is the graph behind. Isn't it? This is the graph behind. Yeah. So now you shift the wave to the right by 90 degree. That means later on this crest here, the top here will go to the y-axis here. So after you shift the wave to the right, it becomes the maximum here. The amplitude here will go to here. Will come to here. So it become like this. Yeah, shift the wave 90 degree to the right. Comes like this. I need to plot first, and then this one also go shift to the right. That means go here, yeah, and then over here, and then here, and then here. Plot first will help you to draw. You understand? Plot first. So I got my graph. So I got my graph already. See that? Nicely done. Okay. Okay. So that's the graph. Yeah. Or shift 90 degree to the right. Shift 90 degree to the right. See that? That is what it means by minus pi over 2. Minus pi over 2. Minus pi over 2. That means the wave. Okay. Okay. Yeah. So you shift the wave to the right. So here also shift to the right. So it become like a cosine graph already. So it's also two wavelength. Okay. So maybe I should rub off the original graph. Then you can see clearer. Yeah. Then you can see clearer. So what graph it becomes? What graph it becomes? Let me check. Yeah. Yep. So the graph it becomes is so it becomes this one lah. Just rub off the rest. Okay. So I remove the original graph. This is the final graph I get for this equation. This is the final graph. Okay. This is the final graph. actually become a cosine graph already. Yeah, if you look carefully. The crest here go to the top here. Go to the top here. So it's just the whole graph shift to the right by 90 degree. When you minus 90 degree in the angle, minus 90 degree, you minus. You minus. You see, if you minus 90 degree in the angle, your whole graph shift to the right by 90 degree also. Shift to the right by 90 degree also. So so that's the final graph for this equation. Okay, for question C. Okay, so for the following videos, I'm going to discuss for D and E. Okay, also use the same method. Okay, bye.